All right, because I was a complete fool earlier when I did this problem yesterday and uploaded it and realized it was completely shaded wrong, I am back doing this again, hopefully a little bit faster, because this video took a long time to do the first time. So we're looking at a clothing manufacturer that had 1,000 yards of cotton, and they're making shirts and pajamas. And a shirt requires 1 yard of fabric. I'm just going to zoom it in here. And the pajamas take 2 yards of fabric. It takes 2 hours to make a shirt, 3 hours to make pajamas. So we're looking at the fact that there are 1,600 hours that are available for making this clothing. So we're looking to write a system of equations, graph it, and find out possibilities of solutions that could be made with this manufacturer. So the first thing I did here, it doesn't really specify which one is which, so I just labeled the x-axis the shirts, the y is the pajamas, and I've already set up the graphing on this. So each line is worth 50, and I went up to 600, and I'll show you why in a second. So x is the shirts, and then we have the PJs as the y. And so if we're looking at our two inequality statements, the first one revolves around the amount of yardage of cotton that we have to use to make the shirts and the pajamas. So we max out at 1,000. It can be equal to 1,000, but it can also be less than that as well. Now, one thing we know is that the shirts require 1 yard of fabric. So if I have a shirt with 1 yard, that would be 1x. And I can also make PJs, which take 2 yards of fabric, which is right there. So we do 2 times the y, which is the PJs, and that would total up to 1,000 or less yards of fabric to be made. Now the other equation, or the inequality statement, I should say, is relating to the time it takes. So we know that there are 1,600 hours available, so it can be 1,600, or it's going to be less. And we know that according to this, 2 hours to do shirts, so we do 2 times the shirt, which is x, and then we also have 3 hours for the y, which is the pajamas. So these are my inequality statements for sure. Now we are only dealing with a positive coordinate system. We're only dealing with quadrant 1. You could also put just the x has to be greater than, could be equal to, technically, 0. And the y also would have to be at least 0, at the minimum 0, or it could be more. So again, we could just particularly make all of them, could be all shirts, all of them could be pajamas if we really wanted to, and so on and so forth. So for this first portion of this, we are just going to take a look at rearranging the equations. We could do that. I'm actually just going to show you quickly what I had here as far as the inequality statements go. So you could use this graphing, and this is the information I did yesterday when I graphed this, to create an inequality statement for y equals mx plus b in that format. This one would have been fine to use. And what I said yesterday was when I did the second inequality, which is down here, we ended up with a weird number, which we got 533.3 repeating. That's just a terrible number to start with. And then having to use -2/3 on the graph, the way that we've got this labeled up, it's just not a great fit. So that's why I'm not going to do that with this graph, and I'll show you a different way to do this in the second part of this when I'm showing you the graphing part, which I promise not to mess up this time when I shade it. Because the graphing was fine, but it was the shading that was the issue. So come back for part 2, and I will show you how to graph this graph, and then we'll talk about the shading on it. If you want more questions like this, you can find them on my YouTube channel, You Want Algebra. Check these out under the linear systems of linear inequalities section.